Bayes' theorem is a crowning achievement of science. It is a plan for changing our beliefs in the face of evidence. So how does it work? Let's start with an example. In a city of 1 million inhabitants, there are 100 terrorists and 999,900 non-terrorists. Thus, the base rate probability of a randomly selected inhabitant of the city being a terrorist is 0.01%, and the base rate probability of that same inhabitant being a non-terrorist is 99.99%. In an attempt to catch the terrorists, the city installs an alarm system with a surveillance camera and automatic facial recognition software. The software has two failure rates of 1%. The false negative rate: if the camera scans a terrorist, the bell will ring 99% of the time, but it will fail to ring 1% of the time. In other words, the probability that the bell doesn't ring given that the camera scanned a terrorist is 1%. And the false positive rate: if the camera scans a non-terrorist, the bell will not ring 99% of the time, but it will ring 1% of the time. The probability that the bell rings given that the camera scanned a non-terrorist is 1%. Suppose now that an inhabitant triggers the alarm. What is the chance that the person is a terrorist? In other words, what is P of T given B, the probability that a terrorist has been detected, given the ringing of the bell? I suggest you pause the video and come up with an answer on your own. To summarize, we have three pieces of information. 1. In a city of 1 million, 100 of the inhabitants are terrorists and 999,900 are non-terrorists. Therefore the probability of randomly selecting a terrorist is 0.01%. 2. The probability that the bell doesn't ring given that the camera scanned a terrorist is 1%. 3. The probability that the bell rings given that the camera scanned a non-terrorist is also 1%. We want to know the probability that a terrorist has been detected given the ringing of the bell. If you're struggling to figure out the answer, you'll be relieved to know that a very small number of people get the correct answer initially. To make it easier, let's rephrase the question as follows. Assuming we scan everyone in the city, 1. What fraction of the population triggered the bell? And, 2. What fraction of these are actually terrorists? That is, we want the number of terrorists who triggered the bell divided by the total number of inhabitants who triggered the bell. Let's start by calculating the number of inhabitants who triggered the bell. One of the easiest ways to understand probabilities is to think of them in terms of Venn diagrams. We have 1 million inhabitants. 100 of them are terrorists, and 999,900 are non-terrorists. 1% of non-terrorists triggered the bell, that is 0.01 multiplied by 999,900, which equals 9,999. This is the number of false positives. We also know that 1% of terrorists did not trigger the bell, that is, 0.01 multiplied by 100 which equals 1. That is the number of false negatives. This leaves us with 100 minus 1 equals 99 terrorists who did trigger the bell. If we add up to number of non-terrorists who triggered the bell to the number of terrorists who triggered the bell, we get the total number of inhabitants who triggered the bell, which is 9,999 plus 99 equals 10,098. Now, what fraction of these people who triggered the bell are actually terrorists? We simply divide the number of terrorists who triggered the bell by the total number of inhabitants who triggered the bell, that is, 99 divided by 10,098 which equals 1% approximately. This is the correct answer. The correct calculation uses Bayes' theorem to take into account the prior probability of any randomly selected inhabitant in the city being a terrorist and the total probability of the bell ringing. The probability that a terrorist has been detected given the ringing of the bell equals the probability of the bell ringing given that the camera scanned a terrorist, which is 99%, multiplied by the probability of randomly selecting a terrorist, which is 0.01%, divided by the total probability of the bell ringing. That is, the probability of the bell ringing given that the cameras scan a terrorist or a non-terrorist. More generally, Bayes' theorem can be written as follows. I hope you found this introduction useful. Check out the links in the description for a more detailed explanation of Bayes' theorem.